Okay, we're going to review really quickly here grade 11 concept where we have tension on a string where we are pulling objects across a flat surface. So let's get our flat surface. Let's have two objects getting pulled across this flat surface, and then there will be our applied force. That's going to be pulling these things across that surface. Let's make this rear one 20 kilograms, and we'll make the front one 15 kilograms, and this will be the tension. And usually in these questions you're asked to find tension, well, acceleration and tension, but if you're asked to just find tension, you have to find acceleration anyway, so you might as well just get into the habit of finding acceleration regardless. With these, you're going to have a force of friction backwards, so we'll call that force of friction 1, and we'll call this one force of friction 2. It doesn't really matter what you call them. And let's say what our applied force is. Let's call it 550 newtons. First, we're going to find the acceleration. Your first step for all of these type of problems. Find the acceleration of the object. No upward forces. You could do tension on a string with a force at an angle. That, I guess, could extend into the grade 12 realm, in which case you would just reduce the normal force on this one, and I'm not going to get into it. But you could do it. This one, though, is totally flat, which means that you're going to have a force applied pulling it this way. You're going to have two frictional forces pulling it back. So let's do our sum of fx's, which means everything that I possibly have as a force on here. That would be my force applied. I'd add that to my force of friction, this second one here, which is in the minus direction. I'd also add that to my force of friction, this first one here, and then I would take my net mass, 15 plus 20, and my acceleration, which will be in the x direction, so I'll throw a little x on there. 550 is my FA. Subtract off my force of friction 2, which is going to be mu Fn. Subtract off my force of friction 1, which would be mu 2, force normal 1, equals my net mass, which I can do that one right now. That'll be 35, because it'll be 20 plus 15, AX. Now, 550 minus, well, I guess I should have told you what the coefficient of friction was. Let's go back and put that up. That will be 0.23. Okay, so there it is. Now I can go back and put this in. 0.23. My normal force for 2 here is going to be 150. I'll subtract that off my 0.23 of my F1, which is going to be 200, equals 35 AX. So, let's see here. That's going to be 550 minus 34.5 minus 46 equals 35A in the x direction. Okay, so I'm going to solve all that out. When I do a whole bunch of work here, my AX ends up being equal to 550 subtract 34.5 subtract 46 divided by 35. So AX ends up equaling 13.4 meters per second squared. Since this thing is moving to the right, call that positive. So there you go. That is your acceleration. Now what I want to do is I want to find, for my second part, I want to find the tension. To find the tension in the string, what you need to do is identify which of the masses this tension is actually applying to. So it's not applying to the 15 because this force that's applied is pulling. So you can think of a rope here. It pulls on this one, and then this rope is attached here, and it pulls this one. So actually, this is the situation where we're going to look at to find our tension, keeping in mind that the acceleration is still to the right, and the acceleration that we're going to use for the 20 is the acceleration of the entire system, which is 13.4. So really what we're going to do is just go F equals MA x net, because it's all of it. And this force is going to actually be, well, let's see here. What do I have? I've got a tension going to the right, pulling it. I have to subtract that off of my force of friction for this first one. So that's there, equals MAX. Tension then will be equal to mass times AX plus my force of friction for my first one. So that's going to give me 20 and times 13.4, and I'm going to add that to 0.23 mu and 200. I guess you could just look back and figure out what F1 was. Where was that? Right there. Just taking that value and put it in, but I'm not going to worry about that. I'll just plug it in all again. Put everything in, you're going to get 46 plus 268. 268 there, 48 there. And so your tension ends up being equal to, when you add that up, 316 newtons. There you go. So that is a grade 11 concept that you should already be familiar with. So here it is. We've gone through it real quick. We'll start curving the surface, so you'll get inclines. We'll start bending it over the edge of tables. We'll start putting this at angles. We'll do all sorts of crazy things to it to make it a lot harder. There you go.